Okay, here we have been asked that there is a set of natural numbers and a relation has been defined on the natural numbers where n and m they belong to natural numbers and n is related with m, where you divide n and m with 5 and it leaves an integer which is 0, 1, 2, 3, 4 and 5, basically integers which are less than 5. We have to show that R is an equivalence relation and we have to obtain the pairwise disjoint subset determined by R. Now listen, here we have to understand one thing, that you take any natural number. If you take any natural number and you try to divide it by 5, the remainder that you will get will always be either 0, 1, 2, 3, 4. That's it. Okay, so any natural number, you can take 23, you can take 28, you can take 436. I'm taking numbers which are not ending with 5 or 0 just to show you that it can either be with, of course if I take 35 it's going to give you a remainder which is 0, and if we take 80 it's going to give us a remainder 0. But otherwise also you try to take any number is going to give you a remainder which is either 0, 1, 2, 3, 4 or 5. Correct? Okay. Keeping this in mind, now basically they have asked us to do what? They have asked us to show that this is an equivalence relation. When is a relation equivalence? When it is reflexive, when it is transitive, and when it is symmetric. Correct? So let's see if this relation is reflexive. Let's prove the relation reflexive first. Now for a relation to be reflexive, it has to, see, let us take any integer a. All right, a belongs to a natural number. A is a natural number. Now if a is a natural number, that means a will be is in relation with a. Now if I divide this by 5 and if we divide this by 5, we might get any one of the remainder 0, 1, 2, 3, 4 or 5. Correct? So they basically we can say that if a belongs to natural numbers and a is in relation with a, therefore we can say therefore it is reflexive. Correct? Therefore what we can say, the relation is reflexive. Correct? So R is reflexive. Okay. Now let's see what happens with symmetric. For a relation to be symmetric, what is the requirement? That if we have A and B, if they both belong to N, and if A is in relation with B, then if we divide both by 5, we are going to get a remainder which is either 0, 1, 2, 3 and 4. So both of them will fulfill the condition of the remainder. Correct? So that means we can say that if A is in relation with B, then obviously B, therefore we can say that B is also in relation with A. Correct? If this, because both of them will be divisible by 5 and both of them will give us the remainder 0, 1, 2, 3, 4, 5 and fulfill the given condition. So therefore we can say that therefore the relation R, so we can say therefore relation R is, here we can remove the R, so we can say relation R is symmetric. Correct? Now let us see what is it with transitive. What is the basic requirement of transitive? Okay, so if we say that A, B, C, if we say that A, B, C are, let's do transitive, A, B, C are natural numbers. Correct? So A, B and C, they belong to natural numbers. Then if we say that A is in relation with B, if we divide both by 5, we are going to get a remainder which is 0, 1, 2, 3, 4. Correct? That means it is fulfilling the condition. So A is in relation with B and B is in relation with C. So if we divide both of them, we will get any of this. So therefore we can say that A is in relation with C, because if you divide A and C, you will still fulfill the condition. Perfect. Therefore we can say that R is transitive. Okay. Now they are talking about the next part is where also obtain the pairwise disjoint subsets. Now we have to find out the disjoint subset, meaning what? Meaning actually disjoint subset means they are asking us to find the equivalence class. when they're asking us to find the disjoint subset, that means they're actually asking us to find the equivalence class. Equivalence class of what? Equivalence class of numbers which are fulfilling the given condition. What is the first condition we have? The first condition is that the remainder has to be 0. So let us take A0. A0 if you see, or A0, that means we have to take, these are set of natural numbers. All the natural numbers which are going to give us a remainder 0 after you divide it by 5 will be a part of this group, correct? This subset. What are they going to be? So first is going to be 5. Then we are going to take 5, 10, 15, 20, 25 and so on so forth up to entire. So this is going to be one set. Let us take numbers which are going to give us remainder 1. 1 meaning 1 itself, because 1 divided by 5 you will get 1. Then you will get 1, then 6, then 6 plus 5 11. 11 plus 5 16, 16 plus 5 is 21, so on and so forth. This is entirely another set. Then you can take A2. A2 will be, first you will divide it by 2. 2 plus 5 7, 7 plus 5 12. So you try to divide any number. 12 plus 5 is going to give you 17. 17 plus 5 will give you 22, so on and so forth. Then you have remainder which will give you 3, which is going to give you 3 first itself. Then 3 plus 5 will give you 8. 8 plus 5 will give you 13. And then this will give you 18. And this will give you 23. So on and so forth. And A4, that will give you remainder like 4 itself. And this is going to give you 9. And this is going to give you 14. And this is going to give you 19. And this is going to give you 24 and so on and so forth. So these are the disjoint sets. You see, these are all the A0, A1, A2, A3, the subsets of the natural numbers, but they are still disjoint subsets, correct? They are not connected to each other. Perfect. So this is what it means. So the question is already solved in the textbook, but if you need the explanation, this is what it is. And if you try to do the union of all these things, you'll basically check, you will get all the natural numbers. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you try to do the union of all this, so A0 union A1 union A2 union A3 union A4, if you try to do all of them, correct, till the end, till what, till the last, till what they have given you in the explanation there. So if you see, it will give you the set of all natural numbers, correct? So I hope you've understood this, correct? And up to, so basically starting in, they have given you like this, so it will give you, this will, if you add all of them, if union of all of them, which is basically a union of all i's, which starting from is, which where remainder is equal to 0 to 4, correct, of all the numbers which are included. This will give you a set of natural numbers. This is exactly how they have written and they have explained it, correct? This is what you have to understand. Getting it? I hope you got it. Okay. Bye bye.